Hello and a very warm welcome to another HAKOM webinar. I'm Stefan Komornyik, co-founder and managing partner at HAKOM Time Series. Like always, our live webinars are recorded and uploaded to our YouTube channel. You will receive a direct link along with a follow-up email right afterwards. Check out our YouTube channel for more in-depth information on Time Series. Please hit the subscribe button to stay up to date. Last time we talked about AI's hunger for energy with a focus on time series management. We pointed out future trends and some exciting features of our platform to reduce energy consumption and improve energy efficiency. Today, we will address a very relevant topic again: authenticity of time series data in the energy sector, with a strong focus on data security and protection. Let's have a look at some interesting figures. According to the 2024 X-Force Threat Intelligence Index by IBM Security, the energy industry already ranks in third place regarding the share of attacks, where 43% of these attacks objectives were a malware infection. A new report from Security Scorecard reveals a startling trend among the world's top energy companies, with 90% suffering from data breaches by third parties over the last year. Based on this, the topic is highly relevant in the energy industry and very likely to keep us busy for some time to come. And there's another important aspect: the dependence on authentic, reliable data for ensuring grid stability. As outlined in the Energy Industry Act, distribution system operators are empowered to alleviate congestion by either reducing the load or temporarily disconnecting certain prosumers from the network. To execute this, DSOs must possess the capability to selectively deactivate portions of the network, trusting data of absolute reliability. This naturally raises many questions. How can we make sure that we use only authentic data, data that has not been manipulated by accident or on purpose? As the lion's share of the data analyzed in the energy industry is time series, that's reason enough for us, as experts in time series management, to take a closer look at this topic today. So, here's today's agenda. We will discuss how the energy transition is accelerating OT-IT convergence. We will investigate the setup of a security architecture to measure and authenticate data. And we will show on a simple smart home use case how to make data authenticity transparent along the entire data lifecycle. With us is Florian Kolb, Chief Commercial Officer and General Manager Energy at Intertrust Technologies based in Menlo Park, USA. He has extensive professional experience in the global energy and Silicon Valley tech industry. Intertrust is co-owned by large energy companies and does extensive R&D in the energy technology space. Sharing his experience, he will explain how innovative device and data protocols will help to set up a persistent data protection system across the value chain for an energy service provider. Our second panelist is Hasleder, co-founder and managing partner at HAKOM Time Series, responsible for product management of the PowerTSM Time Series technology. As you know, at HAKOM we are Time Series, and that especially counts for Thomas. Together with his team, he is constantly pushing the boundaries of our Time Series cloud platform, aiming at making the most complex as simple as possible. Joining Florian, we will show how to guarantee authentic and auditable data throughout the entire lifecycle of time series data. So, let's meet the panelists and jump right in. Hi again, and welcome to our next HAKOM webinar. I say good morning to Florian, who just got up in Silicon Valley. Hi, and good afternoon from Thomas and myself here in Vienna. And once again, thank you for joining, especially those days when an exciting European Championships keeps us busy and somehow distracted. Hope your team stays in the tournament as long as possible. I never tire of repeating how much you motivate us to keep looking for interesting topics. We are particularly pleased with the numerous interactions both during and after our webinars. All of your feedback is welcome and helps us to further develop the format. You're also welcome to make suggestions for interesting topics. I always find that super exciting and often very surprising. So please use the Q&A function. I'm sure you know how it works. In our session at the end, we will again try to answer everything you drop in. Challenge us. We'll do our best again to answer all of your questions. So having said that, Florian, you have spent many years working on many different topics in the energy industry, mostly around innovation and research. And the current topic of your work is security now. Please tell us why this topic is so important and how the energy sector can deal with it. Florian.
Yeah, hello. Thank you. Welcome also to all participants in the name of Intertrust. First of all, congratulations to Austria and the Austrian soccer team who beat the Netherlands yesterday in an epic game. And you have a great German coach. So it all fits together very nicely. Yeah. So my name is Florian Kolb. I'm based here in Silicon Valley. I'm very excited to be here talking about the digital security challenges that are coming along with time series data, AI, IoT, and more in the energy industry. I will share with you the Silicon Valley perspective on this topic. Just a quick framing who we are. We are a Silicon Valley tech company that is structured as a corporate JV. The majority of the company is owned by E.ON from Europe, JERA from Japan, Origin Energy from Australia, and a few other blue chip companies. We are around 140 people focused on advanced software technologies for energy data security, enabling the move to AI, and of course, contributing to decarbonization. What I would like to focus today is the data security layer technology that we provide called explicit private networking, or briefly XPN. We also have other products and technologies around secure virtual power plants and additional digital solutions for the energy industry. We also have recently been picked by the US government for contributing to the first ever AI safety consortium. And we are also a founding member of the Trusted Energy Interoperability Alliance, an open energy data security standard that we are trying to move forward. Before we go to the tech side, let's briefly look at what are some of the key megatrends in the energy industry. On the next slide, please. So, of course, there is a lot of stuff going on in energy. And if I would have to pick two key megatrends that are also relevant for digital, I would pick the increased demand for electrical energy and the increased volatility relevant for grids generation and also the regulatory side of the business. These two trends are the most relevant ones from a digital energy perspective. Also, there is a bit of an artificial intelligence hysteria in energy, of course, and that is also fueled by the colleagues from McKinsey who identified significant improvement opportunities from AI in energy. Researchers suggest between 50 and 300 AI use cases only for grids. This all is based on more data from IoT, and AI also implies the OT and IT convergence. So the fusion and the merging of more OT operational technology related environments with IT related environments. And Linux Foundation, for example, sees that as an indicator for how mature the digital efforts in energy are. One of the downsides of this convergence is that it exponentially grows the attack surface for hackers, attackers, fraudsters, pranksters. Yeah, some of the evidence, Stefan already mentioned some statistics. We see a more than 100% increase of attacks on utilities in the last 2 years. On average, people counted around 1,000 attacks per energy company per week. The cost of a data breach has been researched as around 5 million per data breach per utilities. There is a significant growth and increase in IoT malware attacks. And what's also interesting, that around half of all utility companies are actively pursuing the OT and IT convergence, which on the other hand leads to more risk. So two examples are in February 22, there was a big attack on 5,800 Enercon wind turbines in Germany, which created a big problem. And a more recent one also from February 2024 was an attack on a grid control room provider, which was not good. So this stuff is very, very real. That's the message. Next slide, please. So what are the security problems that we want to solve? So we call this the eggshell defense. So what we see in energy data infrastructures today is often misconfiguration and complex networks that leak and expose unencrypted data. I mean, that's the problem and the risk. And once the intruders are inside, they can move laterally to gain control of resources within the network. So from the outside, the networks are well protected, but once people are in the inside, there is no protection anymore. That's why we call it the eggshell defense, like an egg. And even air gap systems have entry points. So the NSA conducted studies that so-called air gap systems show an average 40 weak points and connections to the internet where intruders could attack and enter these systems. These networks are vulnerable to replay attacks when attackers replicate valid data to spoof the communication. And more conventional approaches like IPsec and TLS also have weaknesses that need to be overcome. Some strategies that we recommend considering. Next slide, please. So first of all, this new challenge requires C-suite attention, which is very important. Also, the current security strategies like air gapping must be extended. We recommend that energy companies prepare for zero trust and start defending the data and not only the data infrastructure, and also plan for a second line of defense. So concrete actions are reviewing the current security setting with an OT-IT convergence lens. Also start thinking about crypto agility and quantum safety. There are interesting studies around the infrastructure, for example, where this is not in a good situation right now. Also, when you're developing an AI strategy, do that with a new security paradigm in the back of your mind. And of course, have a close look at technologies like XPN and support open energy data security standards like TEA. Next slide, please. So some of the technical data challenges, we always quote three. Number one, data communication. Number two, data models. And number three, multi-party data sharing. So with XPN, we focus on data communication side, and HAKOM with its PowerTSM is focusing on data and also the data sharing aspect. So we think this is like a perfect fit throughout the energy value chain. So next slide, please. Let's talk about XPN for a little bit. So XPN is an IoT optimized communication protocol. So what happens with XPN is that data or also commands that are sent from cloud systems, OT environments get a unique fingerprint at the source of the data or thereafter. The fingerprint, which is actually a hash, is used to assure the data integrity. The authenticity and encryption starts right from the beginning of the data, which is very different than traditional approaches. When the data is transmitted around, this fingerprint can be compared all time after the transmission. And it can be ensured that it has not been changed. And the fingerprint itself is encrypted by a private key known only to the source and the server. And so with this concept, we can ensure authenticity and integrity and non-tampering of data all the time. Next slide, please. So where can XPN be deployed? Actually, there are three different areas. So we start with the hardware device and sensor level, or any type of equipment that is digital. That is the ideal case. The further we go down to the true source of the data, the harder the protection with XPN gets. But we can also move to servers and gateways that aggregate data for several purposes, where an XPN vacation can happen. And then also on the data center or the cloud systems level. As I said before, we can assign commands that are generated in cloud systems that are pushed down from the IT environment back into the OT and secure everything is according to the rules and how it should be. Next slide, please. So where does XPN sit? Also comparing to other technologies, XPN is an application layer secure communication service, as already mentioned. It ensures end-to-end data integrity and privacy across any network, protecting the data in transit and at rest, which is like a big differentiator to VPN technologies, for example. It is end-to-end and message-oriented versus connection-oriented point-to-point technologies like VPN, for example, or TLS. XPN is very good for large-scale distributed data networks with many parties, such as energy. It adheres to zero-trust architecture models. It includes explicit authentication of devices and authorization of devices, applications, and the data itself, which is a big difference. And it fixes some of the flaws that we see with traditional concepts such as TSL and VPN. TSL, for example, was developed in 1994. VPN was developed in 1996. So, and there are a lot of weaknesses with these approaches that are very well described and understood. And that's what we are trying to fix. Last slide on XPN, just a brief conclusion. So XPN is built for modern dynamic systems and uncontrolled environments, incorporating a robust trust model. XPN provides persistent encrypted data, securing stored data in intermediate systems. XPN is built from the ground up for dynamic systems and uncontrolled environments, aligning with the zero trust principles that I've mentioned. It's much simpler by design than legacy approaches. And it starts with a modern approach to security where zero trust concepts underpin all data transactions and storage. Stefan will now show you how to embed this authentication in a concrete use case together with the HAKOM technology.
Thanks, Florian. For now, because I've seen some questions coming in already, we'll deal with it in the Q&A. So here goes my reminder. Please ask your questions. We will answer all of them if possible. Thank you for your insights, Florian. Recently, we talked a lot about AI, as you mentioned, Florian. Somehow forgetting that there are many other important data and analytic trends as well. And I invite you to have a look at a study by Park. It's the Data BI and Analytics Trend Monitor 2024. And they asked 2,300 users, consultants, and software vendors about their priorities. And interestingly enough, as you can see, data security and privacy together with data quality management rank highest. So we as a provider of a technology definitely should consider that. So let's take a closer look at those two topics. Doesn't it make a lot of sense to regard data authenticity as being an elementary aspect of data quality itself? And by doing so, we could address both of those megatrends at the same time. That's our idea and approach. And therefore, we should should regard only those data as valid that has been authenticated. And it's not just about checking whether data is plausible, but it's equally important to check whether it is authentic and therefore reliable. And in the following video, we want to take a closer look at what we can do in our time series technology to support this. So let's have a look. Vera, please go on and start our clip. So, connecting Intertrust XPN service with our PowerTSM service, we can create authenticated data throughout the whole data lifecycle. And our challenge is to ensure that time series data coming from various sources is authentic.
It is. Using data encryption services in combination with our PowerTSM cloud can do this.
Very good. So let's have a look. Here we have the different devices where the sensors record the time series data, and those can be wind farms, power plants, smart home devices, and so on. And the sensor data now needs to be sent to the PowerTSM cloud service.
Ideally, the sensors encrypt the data on the chip itself. so that they are safe during the whole journey.
Absolutely. But in short term, it's more realistic that by means of IoT and OT networks, like this, the data is transferred safely to a gateway where it's encrypted. And from there, it's safe for its ongoing journey to the XPN service, which is on the PowerTSM platform.
And this is where the data can be decrypted and where the PowerTSM REST API ingested into the PowerTSM database.
Cool, and doing that, we can make use of our status tags. Now, let's have a look how that looks in our PowerTSM application. The PowerTSM app is smoothly integrated into Microsoft Excel as a plugin with a useful ribbon to choose from various functions. First, I will sign in to our PowerTSM cloud service by presenting my user credentials. Then I will choose a time span and resolution for my report on the data that I will select. And finally, I will choose some time series from smart home sensors in order to show how we can see if data has been transferred securely. There we go with 4 time series from smart home devices that are measured in minute increment. I will report the data in 10-minute increment like this. All data coming in via XPN service will be ingested with status valid. In PowerTSM, we use the color code to represent the quality. Here we see that authenticated data is represented black. For all other data, we introduce a not authenticated flag that makes it easy to see whether the data is authentic or not. Further down the line, and I need to scroll to see that, there's some data flagged not authenticated in the second time series as well. You might be thinking that it's quite annoying to have to check the 10 minutes data to make sure that all the data is authentic. For such cases, we will inherit this information in aggregations. I will show you how this works. In this case, let us simply aggregate to daily grids over the period of 1 month. I will now update the report in daily increment by choosing daily resolution. There we go. In this case, because we have chosen watts as a unit, this is done by calculating the average for the 10-minute data. When aggregating across these time slots, the not authenticated flag will override the other status. So if there's just one single not authenticated data point in the interval, the whole interval will get the not authenticated status. Therefore, you will detect that there is not authenticated data in some time slots at one glance. Aggregating over even longer time spans makes it possible to see whether you have authenticated data available for longer periods. Therefore, I will now report the data for the whole month aggregated over the whole period. Here we go. In this particular example, we see that out of 4 time series, there's only one that shows authenticated data over the whole month. So, using the PowerTSM API in combination with the XPN encryption service makes it possible to use authenticated data only. You can decide, depending on the use case, if it is safe to use some not authenticated data or not. What does this mean regarding various use cases? Let's discuss this right now. After this clip, we want to ask Thomas, he's the product owner of our PowerTSM time series technology. What are the different perspectives for a technology like ours talking about data authenticity? Thomas.
Thank you, Stefan. First of all, there's the quality perspective. We talk a lot about data quality. As we have seen on your previous slide, data quality is key, and even more if it's a mission-critical use case. And we thought of data quality. In the past, we considered things like outliers, plausi checks and gaps and so on, as you can see here on the slide. We spend a lot of time creating features for this, formulas for identifying non-plausible data, calculating replacement values, create a concept for status flags, and a lot more. Florian told us how data and cyber attacks are increasing. Compared to just validated data, isn't the authenticity of data as important, maybe sometimes even more important? What does it help filling gaps in data or creating replacement values if the data itself has been manipulated? I'm a mathematician, and one of the first things I've learned, you can't draw sensible conclusions from false data. In that sense, it does not matter whether the cause is a measurement error or data manipulation. Therefore, the information that data could have been manipulated is of particular importance. So looking at it from that perspective, authenticity is an important quality feature itself. And there's a second important perspective, the auditing perspective. Let me explain what I mean. We know that for many use cases, it is relevant to be able to reconstruct any manipulation of data during its whole life cycle. We need to know who changed the data, how she or he did it, and when. In the energy industry, there are a lot of use cases where this is relevant: trading, scheduling, smart meter clearing, and many more. In the future, as Stefan and Florian pointed out, there will be many more of those. Therefore, in our technology, we support what we call an audit trail. Whenever time series data is being changed, it will be recorded in this audit trail. So we created features that make it possible to reconstruct any time series data for any point in the past. We focused on ensuring traceability within the application that uses and consumes the data. So we took it for granted that we start with the data that has not been manipulated. But what does it help to trace every single change of data in the perfect audit trail, not knowing if you started with manipulated data or not? I would summarize these insights as follows. We need to accept that the audit trail should start where the data originates. And as a change of paradigm, we should not any longer assume that data has not been manipulated. So finally, what are the conclusions for anyone working with the data? We need to introduce the fact that data has been authenticated on a single data point level. Luckily, we can treat it like a quality information. Doing it like that, it will automatically be considered in any kind of calculations. In our little video, Stefan showed it. We must inherit this information so that it will automatically work out for aggregated data, or when we mix authenticated and not authenticated data in any calculation. As I said before, we have created some features for visualizing quality information when reporting data. We can use the same features now for distinguishing between authenticated and non-authenticated data. By default, any data coming in from sources of less trust will be flagged with non-authenticated. Only if it was authenticated data, it should get the valid flag. As a result, we will be able to make sure to use only authenticated data for critical use cases or reporting. That wraps it up from my side. So back to you, Stefan.
Thanks, Thomas, for your conclusions, how to deal with that in our technology. You just talked about use cases, which is the perfect transition. We want your use cases. So Vera, please start our today's call to action. We just saw how to set up an architecture to guarantee the use of authentic data. We also saw that it is important not only to set up the AI model as efficiently as possible, but at the same time we need the features of modern cloud services to get the required performance at the right time. To profit from those capabilities, let's unleash the potential of powerful data encryption services in combination with our time series technology for your specific use case. We have created an efficient process to work out a clear proof of value to make this as straightforward as possible. Together with the experts from Intertrust, we will analyze your use case and show you how to ensure authentic and auditable data throughout the entire lifecycle of your time series data. We have fully standardized this process so that you can take away valuable insights within just a few hours. Challenge us and contact us at PowerTSM@hakom.at to get more information. And now, let's start answering some questions. As always, back to you, Stefan. Thank you. So, seen already some questions coming in. We are available now for that. After the official part of our webinar, just for your information, we will stay in for some more 10 to 15 minutes to answer your questions. For a warm-up and to give me some time to sort out all the questions, I will start with one from myself to Florian. Introducing a security architecture, where should somebody start and how could you create some quick wins? What do you think?
Yeah, so what we typically do is we look for a device or an environment where we have control. So where we can put some code into like the firmware, for example, or to like this via a firmware update remotely or on site. So for example, we have a recent example where we're using like a lab environment for a big from a big energy company that has a gateway, which is like a server that connects data from Siemens machines. So we integrated XPN on this gateway server to authenticate or start authenticating the data and then moving the data from the server OT environment into the cloud. Another example that we just did is we went to the factory of a big energy turbine manufacturer and deployed XPN on the sensor level. A third example is using like a smart home gateway that collects data in people's homes. Yeah, so there are many different possibilities, as I mentioned, where to put the XPN software, and we try to find the place where it's the easiest to implement. There was one question: how hard is it to get implemented? This can take a few hours. It can take a few days. But it's a very light installation mechanism, and we always start with like a pilot or like a demonstration, and then if that is something that works well and we can prove the security, then in the next step we move into production. I have to say this technology is really very new, so we just launched it, and so we are in the earlier phase of deploying this. This is not off-the-shelf stuff that's available since 5 years with like a few hundred or a few thousand systems in the field yet. That's something we are working towards. Nonetheless, we have to say that we as Intertrust, we run very large-scale security systems for digital content, for example, which are building on the same principles, which include billions of keys and devices and things like that, providing security. So we know how these things are working.
Thanks, Florian. We have a lot of other questions. I will take one from Dennis. Will HAKOM support XPN? And if so, when will it be available? We have created this concept that we introduced today with creating this service, or with connecting the services in our cloud service. This can be done for a proof of value on short notice. So it's quite easy to connect those two services, and we will make it available, yes, on demand. So we do not see any problems. And as Thomas and I showed how to represent the fact this data has been authenticated in our technology, as this is available as a quality information, this can be done straightforward. So yes, contact us. We are happy to start a proof of value. With another question: what if the code itself is affected by malware and fakes the data has been authenticated? Well, that's rightfully a question that is, yes, understandable, I think. I would say this is something that software vendors like us need to deal with on a regular basis with some other measures. Maybe Thomas, you want to add something, how we deal with vulnerabilities and so on?
Yes. To ensure the security of the code or prevent the code from infection by malware, we have many strategies in place, like secure development practices, like code review, trusted dependencies to daily check for vulnerabilities, code signing, secure coding standards, security audits, penetration tests, access control via multi-factor authentication, and many more. And we additionally offer our customer to inform them on a daily basis if there are new vulnerabilities in their dependencies of our software with our active security management. So that's the easiest way to get rid of this problem.
Yes, there's something very similar, or another question going into that direction. What if somebody manipulates the data with the API itself? I'd say with this concept that we have in place for auditing everything that is being changed, and we also audit by whom, you can reconstruct at any stage who did it and when, and using measures like multi-factor authentication and so on should take care about this. And I think the whole bunch of all this concept should guarantee for knowing if data has been authenticated or not, even via API usage. maybe another one for Florian. As you have mentioned, 3 approaches for deployment. So can they be categorized as conventional, early computer, and AI systems? Is this,
I saw the question, but I don't really understand.
okay.
Maybe take the one with the overhead, because that's an important one. So,
Okay.
what is the additional overhead that XPN puts?
Go ahead.
That's a good one. So it's very simple. It's 64K per message if we use elliptic curve cryptography, and it's 128K with RSA. Now, of course, you can have like larger messages, smaller messages. So it depends a little bit, but that is the overhead that it is creating. And there's also an additional question here that relates to that. If the architecture is considering encryption and decryption before storage, yes, the architecture is considering that.
Yeah, thank you very much. I see that we are already at the end of the regular part of the webinar. But for those who have time, please stay in, because we still have some questions. We have already answered some questions, and we can do a wrap up for those as well. We haven't talked about all the questions yet. So please stay in. For all of you, I want to announce something new. We see a lively discussion, so that could be relevant. We will send out a short email right away, and it will contain a link to a LinkedIn post where you can continue asking your questions. What we do is we hope to initiate some discussions and stay in touch with our community. So please join in, use that link. And for those who cannot stay, and we have to say goodbye, have a great summer. Please do also subscribe to our next webinar. It will be about how to use copilots in PowerTSM. We will start sending out the invites very soon, so please stay tuned to us, and do not forget, life is a time series. Back again. I would like to continue with one of the questions. Florian texted the answers of some questions. I don't know if all of you noticed that. Namely, it was, I don't know if you mentioned which algorithm you use for the encryption. Florian, maybe you can also do this on the...
Yeah, so no snake oil. Yeah, so we are building off the same Diffie-Hellman algorithms as TLS, using AES ciphers. So that's very important to understand that we use widely understood cryptography for doing what we are doing.
Mm-hmm. Yeah, somebody also asked if there's any substitute to XPN. Basic answer is no.
Well, we don't think there is. So of course, people often say, but blockchains, but the blockchain stuff happens at a different level of the data value chain. So if you use a blockchain, that's great. But if the data that goes into the blockchain is tampered, the blockchain secures tampered data, which doesn't really solve the problem. Yeah. So I think we sit really below that in the value chain, or we try to sit below that as much as possible. And really for large volume data, time series data from sensors, from devices, from stuff that is measuring things related to time in energy, which is almost everything. This is where this technology shines. If I have 5 transactions per month, then maybe there are other smart ways to protect that, and we think there are definitely. But this is maybe not the right use case. Yeah, so we are really talking about the stuff in the grid and power generation, as you mentioned, Stefan, where also in the future a lot of AI will have to come to stabilize the system. Also, flexibility management in energy is an area we are very active in. So virtual power plants, for example, this is where a lot of action takes place, and also a lot of distributed energy resources have to be integrated. And this is where the big security weaknesses can be identified to a lesser extent, like in cloud systems people use from Azure or AWS. We think the security that is existing there is at a very, very high level, but not with the distributed stuff. That's really the area to look at. And we think that also good companies and others that are maybe only indirectly exposed to these data sources have to start projects working on this. If everybody is waiting for somebody else to take action, nobody's taking action.
The old chicken and egg problem.
Exactly.
There's a question going into the direction. I think I would interpret it at which level or at which subscription, the encryption, is it centrally or is it at server level or edge level? I think you showed the options basically.
It's a client server. It's a client server approach. So we try to push the client down as far as possible in the data value chain. So ideally on the sensor, and then the server can sit in the cloud or it can sit in the gateway, or you can also have like server to server authentication. So that's very flexible and scalable architecture, very efficient and very secure.
Yes, in connection with our cloud technology, the server could reside in the cloud tenant, or it could also reside on-prem, obviously.
In the data center, of course, yes.
In the data center, so there are many options, and connecting those two services is quite straightforward. Yes, I think that basically, do you see any questions that I have missed out? There's a question about considering environmental data, hourly data of ozone level, but I think that's more a data acquisition question with no particular relation to authentication. We will follow up on this afterwards, Benias. I will answer this question later on, but I think it's not in relation with authentication. I think, at least I wouldn't interpret it that way. Okay, we've answered, I think, basically all. You also specified exactly the overhead that the encryption generates. It's just 64K per message. I don't know if you mentioned that also.
Yes.
On the audio. Perfect. Okay. Yes. So I think that basically wraps it up. I say thank you to all of you.
Thank you very much.
Yes. It was a pleasure having you, Florian, and answering the questions and presenting the concept. And we're looking forward to you contacting us. We would love to go for a proof of value concept and have a look at your use case. So once again, have a good summer. And don't forget, life is a time series. Bye.
Bye.